micro and nano robots. The field of micro robotics covers the robotic manipulation of objects with dimensions in the millimeter to micron range, as well as the design of fabrication of autonomous robotic agents that fall within the size range. Nanorobotics is defined in the same way, only for dimensions smaller than a micron, with the ability to position and orient objects with micron and nanometer scale dimensions. Manipulation at each of these scales is a promising way to enable the assembly of micro and nano systems, including micro and nano robots. Progress in robotics over recent years has dramatically extended our ability to explore, perceive, understand, and manipulate the world on the variety of scales extending from the edges of solar system to the bottom of sea down to individual atoms. Micro and nano robotics research has progressed from these seemingly far out concepts to reality when micro electromechanical systems MEMS began to emerge in the late 1980s. These building blocks took the form of surface micro machined micro motors and micro grippers made of polysilicon fabricated on a silicon chip. In the late 1980s and early 1990s, more concrete suggestions on how one could realize MEMS-based micro robotic devices using such micromotors. Today, a variety of micro robotic devices are enabling new applications in various fields. Other important fields include biology, manipulation, capturing, sorting, and combining cells, and medical technology. In surgery, the use of steerable catheters and endoscopes in very attractive, and development of increasingly small micro robotic devices is rapidly progressing. Wireless untethered micro robots that will explore and repair our bodies, swallowing the surgeon, appear to simply a matter of time. In fact, endoscopy using wireless capsules are already on the market and allow the endoscopic imaging of entire gastrointestinal tract, something currently not possible using standard scopes. Nanorobotics represent the next stage in miniaturization for maneuvering nanoscale objects. Nanorobotics is a study of robotics at nanometer scale and includes robots that are nanoscale in size. That is, nanorobots and large robots capable of manipulating objects that have nanometer dimension with nanometer resolution, nanorobotic manipulators. The field of nanorobotic bring together several disciplines, including nanofabrication process used for producing nanoscale robots, nano actuators, nano sensor, and physical modeling at nanoscales. Nanorobotic manipulation technologies, including the assembly of nanometer sized parts, the manipulation of biological cells or molecules, and the types of robots used to perform these types of tasks also form a component of nanorobotics. By the early 1980s, scanning tunneling microscopes (STMs) radically changed the way in which we interacted with the even regarded a single atom and molecules. STM and other nanomanipulators are nanomolecular machines that use bottom-up strategies. Although performing only one molecular reaction at a time is obviously impractical for making large amount of product, it is a promising way to provide a next generation of manipulators. Most important, it is possible to realize the directed assembly of molecules or supermolecules to build larger nanostructure through nano manipulation. The products produced by nano manipulation could be the first step of bottom-up strategy in which these assembled products are used to self-assemble into nano machines. One of the most important applications of nanorobotic manipulation will be nanorobotic assembly. However, it appears that until assemblers capable of replication can be built, the combination of chemical synthesis and self-assembly are necessary when starting from atoms. Groups of molecules can self-assemble quickly due to their thermal motion, enabling them to explore their environments and find complementary molecules. However, it is clear that nanotechnology is progressing towards the construction of intelligent sensors, actuators, and systems that are smaller than 100 nanometers. These nano electromechanical systems will serve as both the tools to be used for fabricating future nanorobots as well as the components from which these nanorobots may be developed. Shrinking device size to these dimensions presents many fascinating opportunities, such as manipulating nano objects with nano tools, measuring mass in femtogram ranges, sensing forces at piconewton scales, and introducing gigahertz motion, among other new possibilities waiting to be discovered. These capabilities will of course drive the tasks that future nanorobots constructed by the NIMS will perform. NIMS and the components of nanorobots will be the products of nanorobotic manipulation. Large nanorobotic manipulators will be able to shrink the size due to this development, thus enabling nano-sized robot manipulators and other forms of nanorobots. All of these form the scope of the area of nanorobots. Thank you.